In section 2, we move to something called a conditional statement. With a conditional statement, we can write it in if-then form, such as if P then Q. This tells us when we have something with the if, the then part must happen. We'll use the words hypothesis and conclusion, and the hypothesis is the part that always goes with the word if. Those are the things that we have to have, then tells us what must follow after we have them. Notice this little arrow symbol here is another way of writing if P, then Q. Now, if we are asked to identify the hypothesis and conclusion of a statement, we look at what's with if, and that will be our hypothesis. Then we look at what's following then, and that will be our conclusion, that they are collinear. And notice how I've changed the grammar here a little bit, because here they say they, because we've already referred to points A, B, and C. But here in my conclusion, I went ahead and say what they means. On the next one, notice it's not an if-then form. In fact, the if is on this part of the sentence. Well, that means the if part is over here. That's going to be our hypothesis. The Tigers win their next game. Again, I substituted the Tigers for they. The conclusion then would be the beginning part of this statement, that they're going to play in the tournament. That's what's going to happen. If they win, then they will play in the tournament. If we're asked to identify the hypothesis and conclusion and a statement does not have an if or then involved, but instead uses the word is, we're going to just read it from left to right. This is our subject on this side. An angle with a measure greater than 90. The is tells us what must follow. Therefore, this side is our conclusion because it tells us what must follow from our subject, or it's describing our subject. So in this one, we could write it as if an angle measure is greater than 90, then it is an obtuse angle. The next part, we're looking for the truth value. Now, truth value is either going to be true or false. When we're determining truth value of a statement, we always have to look at the if part. So in this one, if you get 100 on your test. Whenever we're talking about the if part, it's very important that we fulfill this. If we don't fulfill this first part of the sentence, then we don't know if this sentence is true or false. What we want to look for is, do we have this first part? And we want to know if the second part must follow. So if we're looking for true or false, we're just looking for situations that support this, or really we're maybe looking for a counterexample where it doesn't work. So the first one, you get a 100. Notice that fulfills my hypothesis. Now if we compare that to my conclusion, your teacher gives you an A, then it matches exactly what should happen according to the statement. So this statement is supporting our conditional statement. In the second one, notice you get 100%. That also fulfills the original statement. Only in this one, your teacher gave you a B. That's a problem because the teacher was supposed to give you an A. That shows that the original sentence, this sentence here, which told us what was supposed to happen, isn't true because we had this, and we had the hypothesis, and the conclusion did not follow. Now in the next one, we also get an A, but notice the hypothesis here is not fulfilled. So since we're not fulfilling this part of the hypothesis about getting 100, this neither confirms nor denies our original conditional statement. We can still say our original statement is true. In the next one, it's the same thing. It talks about getting an 85. That has nothing to do with our conditional statement. So again, it doesn't contradict our original statement. It doesn't support it. But our original statement is still held to be true because this doesn't contradict it. Now there are also 4 kinds of conditionals that are related to the if-then. The basic one is called a conditional, if something, then something. So in this case we're looking at if it's a dog, then it has fur. Now there's something called a converse. With the converse we're going to switch the order. Basically I'm switching P with Q, saying if it has fur, then it is a dog. If we look at the inverse then, the inverse is a negation of the conclusion in a hypothesis. Okay, so notice what I'm saying. I'm saying not P, then not Q. So if it is not a dog, then it does not have fur. So we're just putting the word not into our original statement. The contrapositive then is turning around what we did with the inverse and saying if not Q, then not P. If it does not have fur, then it is not a dog. Now notice something about these. If we look at this, if it is a dog, then it has fur, we could say that that's a true statement. But if I turn it around, if it has fur, then it is a dog, I can find a counterexample for that, like a cat has fur, but is not a dog. So this statement is now false. Same thing with the next one. If it is not a dog, then it does not have fur. Well, my cat is not a dog, but it does have fur, showing that this sentence is also false. The contrapositive, though, if it does not have fur, then it is not a dog, would be true because we already said if it is a dog, it has to have fur. So as we go through these, the conditional and the contrapositive will always have the same truth value. So if the first one's true, it will also be true. These two will also always have the same truth value. However, sometimes this may be false and this may be true. Or they might all be true or they might all be false. We can also look at how some conditionals are related. If we're given a sentence like linear pairs of angles are supplementary, we need to first write it in if-then form. Again, this is like having the word is that's going to separate it into two parts. The subject will be our if part. The then will be what has to be following from that subject. So the conditional would be if two angles form a linear pair. Okay, because I wanted to make it a little more specific. I'm not writing it the same way that they have it here. What are we talking about? We're talking about two angles. Then those two angles are supplementary. The converse then, I'm just going to take those same words and I'm going to switch them around. But notice how I've changed the wording a little bit here. So I now have if two angles are supplementary, then they are a linear pair. The inverse then, I have to go back to my original conditional, but throw in the word not. So if two angles are not a linear pair, then they are not supplementary. So I have the same order, I'm just putting the word not, and the contrapositive is going to flip it around. If two angles are not supplementary, then they are not a linear pair. If we're also asked to find the truth value of these, decide if they're true or false, and also if they are false, give a counterexample. We want to look at what this actually means. If two angles form a linear pair, so I can start by drawing a linear pair. Then they are supplementary. Now I can see from this picture that these two angles come together, form a line, which means they're giving me 180 degrees, so they have to be supplementary. I consider then, can I draw this a different way that would make this untrue? And I can't. By definition, this has to make a straight line, so this will always give me supplementary angles. The converse of this says that two angles are supplementary. Well, I can draw two supplementary angles that are not connected, which means they're not giving me a linear pair. That contradicts my conclusion, making my converse false. In the next one, it says if two angles are not a linear pair, well, again, I can draw the same picture. They're not supplementary? Well, that's not true. If I have 120 degrees and 60 degrees, then they are supplementary. They're also not a linear pair, and so this statement, the inverse, is also false. The contrapositive then, if two angles are not supplementary. Well, if they're not supplementary, they cannot add up to 180 degrees. Even if I make them adjacent, then they're not going to give me a linear pair. There's no way that I can have a linear pair without being supplementary. So this statement is true.